This is a mini lesson for writing equations for piecewise functions. If you recall, a piecewise function looks like this. So we have multiple different pieces that may or may not be linear, and we have different domains or regions of x where the different pieces occur. So in order for us to write a piecewise function, we're going to have to determine the regions for x and the equation of each segment or array within each section. So I'm going to call this graph right here f of x. And I actually like to start by determining my regions. So I could draw in vertical lines, dashed ones, if I wanted to see where everything is occurring. So the first section, this one right here, occurs when x is less than or equal to, I know that because it's a closed circle, -7. And then the next segment, this one right here, occurs between when x is -7 and when x is -6. And I have open circles at both ends, and therefore I will not include the or equal to there. And then I have a third section down here, and that occurs, I see the arrow points to the right, so it starts when x is at -6 and continues all the way to infinity as far as we know. So x is greater than or equal to -6. Sometimes you see this just with a comma. Sometimes you see this with the word if. So I'm going to write if here. And then I need to come up with the equation for each segment. So let's start with this one right here. So this is just the line, essentially, y equals 3. And so I'm just going to say 3 if x is less than or equal to -7. Then the next section here I can mark in red. We see that it has a slope of 3, but we don't know the y-intercept, so we need to actually solve just like we normally would. So I could start by picking a point. I'll use the point -6, 10. And I also know that my slope here is 3. I also could write 2 points if I wanted. So in y equals mx plus b, I have 10 equals 3 times -6 plus b. 10 equals -18 plus b, so 28 is my y-intercept. And therefore my equation, if I were to draw that whole line, would be y equals 3x plus 28. So I will write 3x plus 28 over here for this segment. It is important to check that, so I would notice, okay, yeah, the slope is 3, and if I continued this up, not only do I know that 28 is realistic, I know that it's going up 1, 2, 3, 4, 5, 6 times 3, because the slope was 3, so 18 more above this point. So we have all these different ways we could check that. And then we'll do this final segment, which I will mark in this purple color here. And so first I want to identify some points here, and unfortunately I noticed that my y-intercept is a fraction, but not a big deal. So I can pick a point on my line. I'll use the end point there, so -6, -5. And I know that the slope is -1/5. I can see it's going down 1 over 5, down 1 over 5, down 1 over 5. And then I need the y-intercept. So because this is going down 1/5, I know that this is actually like down 1/5 from this point right here. So our y-intercept is at -6 1/5. I will go ahead and write that, but then I'll actually show you like how we would solve for that. So y equals -1/5 x minus 6 1/5. However, most of us probably would actually go through the process of solving for b here. So we would have y equals x plus b. So -5 equals 6/5 plus b. And you either would say, okay, well, let's subtract 1 1/5 here from both sides, which is equivalent. I just changed the form of 6/5. So we'd have -6 1/5 equals b, which is what I had before. Or from this step, maybe you turn that into -25/5 equals 6/5 plus b. Subtract the 6/5 from both sides. Whichever method you're more fluid with is the method you should use. I just always think like, now that I see -31/5, if I'm checking to see if that makes sense, I would still then convert that into a mixed number to make sure that my y-intercept is realistic. And then we just want to, we want to double check each of our equations here, that each of these are correct. We want to make sure that we don't have any overlap here with our domain. So we know that this is defined when x is less than -7. We don't have the or equal to, which is good here. So then we have -7 through -6, and then x is greater than or equal to -6. So I have my closed circles and I have my open circles here.